of 5 mm. Let us begin with the session.
Let us now look at the objectives of the session. At the end of the session, you will be able to mark eccentricity, set the job for eccentric turning in a 4-jaw chuck and turn, mark concentric and eccentric center lines of a job by using a vernier height gauge. Tools and equipment requirement for this exercise are as follows. Lathe, 4-jaw chuck, chuck key, tool post key, taper turning attachment, cutting tools, vernier caliper, steel rule, universal surface gauge, marking media, vernier height gauge, V-block with clamps, center drill, center punch, dot punch, ball peen hammer. Through this exercise, let us learn how to perform eccentric turning to create simple eccentric with diameter of 22 mm and throw or offset of 5 mm. Check the raw material size using vernier caliper and steel rule. Mount the job in an independent 4-jaw chuck with help of a chuck key. Check the trueness of the job using a surface gauge by keeping the maximum length outside the chuck. Face one end of the job. Plane turn the work to a diameter of 40 mm to maximum length. Unclamp the workpiece and reclamp by reversing it and check the trueness of the workpiece again. Set the facing tool and face the other end to maintain a total length of 50 mm. Turn to reduce the diameter to 40 mm and remove the job from the chuck. Clamp the finished turned rod in the V-block with the help of the clamps. Apply marking media to both the end faces of the workpiece. Adjust the height gauge to a length to locate the center of the workpiece. Scribe and mark the concentric center of the workpiece on any one end faces. Add 5 mm to the existing reading and adjust the height gauge to locate the eccentric center. Scribe and mark the eccentric center of the workpiece. Witness mark the concentric and eccentric centers using a center punch and a ball peen hammer. Scribe a guide circle of diameter 22 mm with the eccentric center as the center point using a divider. Witness mark the eccentric circle using dot punch and ball peen hammer. Hold the job in a 4-jaw independent chuck on the turned diameter. Position the workpiece in the jaws such that the center lines are centered with respect to the jaws. Through the concentric center in line with the lathe center using a universal surface gauge. Open one jaw and tighten the opposite jaw so that the center of the work moves. Repeat the operation till the eccentric center comes in line with the lathe center. Check the trueness of the workpiece with reference to the 22 mm diameter eccentric circle with the help of the surface gauge. Now, turn in steps to form an eccentric diameter of 22 mm to a length of 25 mm. Deburr the workpiece using a smooth file. Unclamp the workpiece and inspect visually. Measure and ensure the diameter 22 mm of 25 mm length using a vernier caliper. Measure and ensure the diameter 40 mm of 25 mm length using a vernier caliper. Apply a thin coat of oil on the workpiece and preserve it for further inspection. To recap, we have learned to mark eccentricity, set the job for eccentric turning in a 4-jaw chuck and turn. Mark concentric and eccentric center lines of a job by using a vernier height gauge.
So that's all about making a simple eccentric with diameter of 22 mm and throw or offset of 5 mm. See you in the next session. Hello and welcome to the session on measurement with scale and outside calipers to plus or minus 0.5 mm accuracy. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to select the right capacity caliper for measurement. Set the size in caliper. Read the sizes by transferring them to a steel rule. Tools required for this exercise are outside calipers, spring and lock joint, steel rule, wooden block, mallet. Let us learn about the types of calipers used in a workshop. Inside calipers. They are used to measure the internal size of an object and distance between surfaces. Outside calipers. They are used to measure thickness and outside diameters of objects. The calipers are available in various capacities and forms. They are available as lock joint, spring, and digital calipers. A 150 mm capacity outside caliper can measure sizes from 0 to 150 mm. Let us now understand the sequence to measure the diameter of a workpiece using outside calipers and steel rule. Open out the jaws of the calipers until they pass clearly over the diameter to be measured. The work must be stationary when measuring the sizes. Place one point of the leg over the workpiece and get the sense of feel of the other point of the leg. If there is clearance on the other point of leg, gently tap the back of one leg of the calipers until it just slips from external diameter of the workpiece to give the right sense of feel. The accuracy of reading depends upon the sense of feel of the user, and hence high care should be exercised to get the correct feel. In the case of spring outside calipers, adjust the screw nut so that the adjustment of the jaws just slips from the external diameter of the workpiece to give the right sense of feel. When you have adjusted the outside caliper for the correct feel, transfer the measurement to a steel rule. The point of one jaw must be placed over the graduation so that the point of other jaw is parallel with the edge of the steel rule. Let us now measure the various workpieces using outside calipers and steel rule. Clean the outside calipers and steel rule. Ensure that the jaws of the calipers are moving freely. Clean all the workpieces to be measured. Diameter of the given workpiece is 45 mm. The length of the given workpiece is 67 mm. The length of the side of the square bar is 40 mm. The length of the given workpiece is 103 mm. The diagonal length of hexagonal bar is 47 mm. The length of the given workpiece is 65 mm. To recap, we have learned to select the right capacity caliper for measurement. Set the size in caliper. Read the sizes by transferring them to a steel rule.
So that's all about measurement with scale and outside calipers to plus or minus 0.5 mm accuracy. See you in the next session. Hello and welcome to this session on two-step turning within plus or minus 0.06 mm with different shoulders undercut on outside diameter. Let us begin with the session.
Let us now look at the objectives of this session. Perform different shoulder turning operations. Check the squareness of a square shoulder. Measure chamfer of beveled shoulder. Check the radius of a filleted shoulder with gauge. Check the depth of the undercut shoulder. The tools required to perform this exercise are steel rule, outside calipers, chuck key, facing tool, turning tool, parting tool, chamfering tool, lubrication oil with can, radius gauge. Step turning is the process of machining a cylindrical shaft with at least two different diameters. The small diameters are produced by removing material using a single point cutting tool so that there is a step change where the diameter changes. While performing step turning operation, different types of shoulders can be machined, and they are square shoulder, beveled or angular shoulder, filleted shoulder, undercut shoulder. Let us now learn the sequence for step turning different shoulders. Check the dimensions of the specimen using outside calipers and steel rule. Hold the job in a 3-jaw chuck. Perform facing operation on one end of the workpiece. Perform turning operation to reduce the diameter to 35 mm for the maximum available length outside the chuck. Reverse and refix the job. Perform facing operation on the other end of the workpiece such that the total length of the workpiece is 100 mm. From the faced end, perform turning operation to a length of 55 mm to obtain a diameter of 32.5 mm. Make a dot punch mark at the center distance from the faced end where shoulders must be machined. When layout for a filleted shoulder, make allowance for the radius to be cut. For a filleted shoulder of 1.5 mm radius and 60 mm from the end of the workpiece, the layout should be 58.5 mm from the end. By using a 1.5 R radius tool, remove 0.5 mm diameter and turn up to 60 mm length as per drawing to obtain a filleted shoulder. Perform turning operation to reduce the diameter to 28 mm for a length of 40 mm from the faced end. Perform the chamfering operation to obtain a beveled shoulder of 2 mm by 45 degrees as per the sketch. Cut a light groove with the point of a sharp tool bit around the circumference of the work to mark the required length. Perform the turning operation to reduce the diameter to 26 mm for a length of 15 mm from the faced end. By using the side knife tool, obtain a square shoulder as per sketch. Let us now learn the sequence for turning undercut. Set undercutting tool on the tool post to correct center height. Make a dot punch mark at 70 and 75 mm from the faced end where shoulders must be machined. Apply chalk and layout die to the small diameter as close as possible to the undercut shoulder location. Bring the point of the tool bit in until it just moves the chalk or layout die on the face and set the top slide graduated collar to 0. Apply a cutting fluid to assist the cutting action and produce a good surface finish. Retract the cutting tool by turning the cross slide handle anti-clockwise. Repeat the above procedure until the undercut shoulder is machined to the correct depth. Do's and don'ts. Choose the RPM depending upon the diameter. Set the tool properly. Make sure you are getting different shoulders as per drawing. Check the steps by using a vernier caliper. Use sufficient coolant. Remove the sharp corners. Check all dimensions. To recap, we have learned to perform different shoulder turning operations, check the squareness of a square shoulder, measure chamfer of beveled shoulder, check the radius of a filleted shoulder with gauge, check the depth of the undercut shoulder.
So that's all about step turning within plus or minus 0.06 mm with different shoulders undercut on outside diameter. See you in the next session. Hello and welcome to this session on male taper turning by taper turning attachment offsetting tailstock. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to produce male taper by taper turning attachment method, knurl the surface, calculate the amount of offset according to the expression of taper, turn the external taper by tailstock offset method. The tools required to conduct this exercise are steel rule, outside calipers, facing tool, center drill, chamfering tool, taper turning attachment, knurling tool, drill bits, drill chuck, parting tool, boring tool, vernier bevel protractor, and vernier calipers. Taper turning attachment for creation of tapers is used for long tapers, power feed, internal tapers, taper angle less than 7 degrees. The attachment has a guide which is fixed along the bed and can be moved to the required taper angle using a screw mechanism. A sliding block mounted on the guide is connected to the cross slide through a pivot joint. The cross feed is disengaged. The cross slide along the tools moves with the guide. When the position of the guide is changed by an angle, the required taper angle is obtained on the workpiece. The required depth of cut can be given using compound slide. Let us now learn the sequence to produce external taper by using taper turning attachment. Check the size of the raw material. Hold the material in a 3-jaw chuck. Perform facing operation on one end. Make a center drill on the faced end. From the faced end, perform turning operation to a length of 22.5 mm to obtain a diameter of 20 mm. Chamfer the end to 1/45 degrees. Reverse the work and clamp in the jaw. Perform facing operation and ensure that the total length remains 75 mm. Make a center drill to hold the job between centers. From the faced end, perform turning operation to a length of 15 mm to obtain a diameter of 16 mm. Set an angle of 5 degrees 45 inches on the taper turning attachment and obtain the external taper by providing the feed for a length of 37.5 mm. Let us now learn the sequence to produce taper by tailstock offset method. Check the size of the raw material. Hold the job in between centers. Perform step turning operation for 15 mm to obtain a diameter of 12 mm. Reverse and refix the workpiece between the centers. Step turning operation for 15 mm to obtain a diameter of 12 mm at the other end. For this exercise, taper must be given from a diameter of 32 mm to a diameter 22 mm over length of 109 mm. The calculation for offsetting the tailstock for this taper is as follows. Large diameter 32 mm minus small diameter 22 mm divided by 2 multiplied by total length of the specimen 180 mm divided by length of the taper 109 mm. The tailstock must be offset by 8.25 mm. Perform the taper turning operation by offsetting the tailstock. Similarly, perform the other taper of 32 mm to 22 mm over a length of 20 mm by offsetting the tailstock by 13.85 mm. Check the size of the job with a vernier bevel protractor and vernier caliper. Safety precautions. Remove the sharp corners. Use coolant while center drilling and taper turning. Use slow speed while knurling. Use plenty of coolant while knurling. To recap, we have learned to produce male taper by taper turning attachment method. Knurl the surface. Calculate the amount of offset according to the expression of taper. Turn the external taper by tailstock offset method.
So that's all about checking the male taper turning by taper turning attachment, offsetting tailstock. See you in the next session. Hello and welcome to the session on female taper turning by taper turning attachment. Let us begin with the session.
Let us now look at the objectives of this session. At the end of the session, you will be able to produce female taper by taper turning attachment method. Knurl the surface. Perform chamfering operation. The tools required to conduct this exercise are steel rule, outside calipers, facing tool, center drill, chamfering tool, taper turning attachment, knurling tool, drill bits, drill chuck, parting tool, boring tool, vernier bevel protractor, and vernier calipers. In a lathe machine, taper turning means to produce a conical surface by the gradual reduction in diameter from a cylindrical job. The taper can be external or internal. If the workpiece is tapered outside, it is an outer taper or male taper or external taper. If it is tapered inward, it is an internal taper or female taper. Let us now learn the sequence to produce internal taper by using taper turning attachment. Check the size of the raw material. Hold the job in a 3-jaw chuck. Set the tool to correct center height. Face one end of the job. From the faced end, perform turning operation to a length of 45 mm to obtain a diameter of 44.75 mm. Make a center drill on the faced end. Set the knurling tool, diamond cut, to correct center height. Knurl the job to a length of 40 mm. Drill pilot hole of 10 mm diameter. Enlarge the hole to diameter 16 mm by drilling. Chamfer to 2 mm by 45 degrees. Set the parting tool to a center height and cut off to a length of 40 mm. Hold the knurled job and face the parted end to maintain a length of 37.5 mm. Chamfer this end to 2 mm by 45 degrees. Set an angle of 5 degrees 45 inches on the taper turning attachment. Set the boring tool to the correct center height. Turn taper and obtain the internal taper by providing the feed for a length of 37.5 mm. The male taper produced by taper turning attachment in the previous exercise should be used to match the male and female tapers. Check the taper angle on the male taper and the female taper using vernier bevel protractor. Match the internal and external taper. To recap, we have learned to produce female taper by taper turning attachment method, knurl the surface, perform chamfering operation.
So that's all about checking the female taper turning by taper turning attachment. See you in the next session. Hello and welcome to the session on drilling on lathe step drilling, drill grinding practice. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to turn outside diameter to an accuracy of plus or minus 0.1 mm. Drill a hole to the required size by hand feed. Step drill the previously drilled through hole to correct depth. Drill grinding practice. The tools required for this exercise are steel rule, outside calipers, inside calipers, chuck key, facing tool, turning tool, drill bits of various sizes, pedestal grinding machine, drill gauge. Drilling is a metal cutting process carried out by a cutting tool to make circular holes in solid materials. The multi-point cutting tool used to make holes is called drill. The different types of drills are flat drill, twist drill. Twist drill can further be classified as tapered shank and straight shank drills. Flat drill. It is the earliest form of drill and is easy to operate. Nowadays, it is not being used because of its poor efficiency. Twist drills is the most used type of drill bit. It has two or more spiral or helical flutes formed along its length. The two basic types of twist drills based on the shape of the shank are parallel or straight shank and tapered shank. Parallel shank twist drills are available below 13 mm in size. Let us now learn the sequence to drill and step drill on a lathe. Check the dimensions of the workpiece using outside calipers and steel rule. Hold the job in a 4-jaw chuck using a chuck key. Perform facing operation on one end of the workpiece. Perform center drilling operation on faced end of the workpiece. Drill the job with a diameter 12 mm drill bit throughout. Fix a diameter 20 mm drill in the tailstock spindle. When feeding the drill bit for step drilling, first touch the drill to diameter 12 mm hole and note down the reading on the graduated collar of the tailstock. Feed the diameter 20 mm drill to 25 mm length with the help of a graduated collar of the tailstock. Perform turning operation to reduce the diameter to 45 mm to maximum available length. Reverse the job and reset it. Face the other end to maintain a total length of 40 mm. Turn the remaining portion to diameter 45 mm. Deburr the job. Check the dimensions. Let us now see the procedure for sharpening of drills. Check that the surface of each wheel is running true and that the wheels are dressed clean. First, hold the blunt twist drill properly with both hands. Then, place the drill on tool rest. Touch the cutting edge of a twist drill in grinding wheel face, maintaining 31-degree angle from grinding stone. Twist drill slightly on wheel face and then grind one cutting edge to the required angle to get 59 to 60 degrees. Grind the other cutting edge to the required angle to get 59 to 60 degree, maintaining the cutting edge's length equal. Check the cutting angle, lip angle and cutting edge length using drill gauge. Switch off the grinding machine and clean properly. Let us learn the precautions to be taken while sharpening drills. Wear proper personal protective equipment. Ensure that the tool rests are adjusted correctly and tightened. Swing the shank of the drill slightly downwards while grinding. While sharpening the drill, the cutting edge's length and angles should be equal. Never resharpen a cracked or split drill. Avoid overheating the drill. Cooling a drill rapidly by quenching in freezing water may cause cracking of the cutting edge. To recap, we have learned to turn outside diameter to an accuracy of plus or minus 0.1 mm. Drill a hole to the required size by hand feed. Step drill the previously drilled through hole to correct depth. Drill grinding practice.
So that's all about drilling on late step drilling, drill grinding practice. See you in the next session.
नमस्कार, मैं दिव्यांशी चौहान।
नमस्कार, मैं भगवती जबनाल। आप सभी का सीएससी कड़ी की तीसरी चर्चा में आपका स्वागत करते हैं।
हमने अभी तक बात की सीएससी सेवाओं के बारे में, जिसमें त्यागी सर ने हमें सीएससी का एक ओवरव्यू दिया। साथ ही हमने बात की पीएमजी दिशा योजना के बारे में।
अभी तक हम सुनते आए हैं